Hello, my name is Jim DeFabia, and I'm the documentation lead for the HPCC Systems Platform team. With me today is Chris Lowe, Senior Software Engineer, and also a part of the platform team. This morning, we're going to talk about running a containerized platform locally. But first, a little bit of housekeeping. We want you to know that we welcome your questions. Just post them in the chat. Feel free to post questions at any time during the session, and one of us will respond. We might not know the answer, but we'll try our best. If you like, you can also reach out to either one of us, and we can set up a meeting at a convenient time during or after this conference. Now remember, this talk is intended for the wider open source HPCC systems community. It's advised that you check with your organization for any specific security protocols involved with running the platform this way. So what is the Containerized HPCC Systems Platform? Well, it's the same platform you already know and love. The main difference is that a containerized deployment uses ephemeral nodes instead of static ones. Now, how does it do that? First off, we use Docker. Docker is an OS level virtualization tool to deliver software in packages called containers. Next, we use Kubernetes. Kubernetes automates application deployment, scaling, and management. And on top of that, we use Helm, which is a tool that streamlines installing and managing Kubernetes applications. And we can tell that these were all intended to work together because they all use the same nautical metaphor. Now, what can you use this for? Well, learning and training, ECL development, unit testing and code review, demonstrations, proof of concept, just about anything short of production. But it's very important that you know your limitations, or rather the limitations of your machine. Remember, you're running this all on your local machine, and you don't want to get it overloaded. So what do you need? Well, for Windows, there's a lot of different options. You can use Docker Desktop and Windows Subsystem for Linux 2 and Helm, or you can use Docker Desktop and Hyper-V and Helm, or you can use Docker, kubectl, Helm, and Minikube. For Mac, Docker Desktop works quite nicely, and you need Docker Desktop and Helm. Now for Linux, there is no Docker Desktop available, so you want to use Docker, Helm, and Minikube. If you're using Docker Desktop with Hyper-V, you probably want to adjust the resources to a minimum of 4 GB of memory and 2 CPUs if possible.
So you might want to ask, why should I pick one set of tools over another? There are many reasons, including whether you use WSL or Hyper-V. This might be dictated by organizational policies or VPN restrictions. For Docker Desktop users, there is a new pricing plan, so please be aware. For all Linux users, well, Linux doesn't have Docker Desktop available. However, Minikube is free. And also, Minikube is useful inside a Linux virtual machine.
So let's examine the steps. First thing we'll do is add a repository. And for that, we use the Helm repo add HPCC, and then the URL for the HPCC repo. You only need to add this one time. Later, you should get in the habit of issuing a Helm repo update command. That makes sure you have the latest information from all of your Helm repositories that you've added. Next, we'll install the default platform using the command helm install my cluster, which is an arbitrary name that I've given my cluster, HPCC/HPCC, and then -- version equals, and I used 8.2.18. The version argument is optional, but we recommend it. It ensures that you know what version you're installing. If omitted, you'll get the latest non-development version or the latest gold version. Next, you use the kubectl command line interface to check the status of your deployment. And the command for that is kubectl get pods. And if you notice in the little black screenshot there are 2 columns, ready and status. And you want to see the status column, you want to see that everything is running. And in the ready column, you want to see that the numbers match. So those are the containers and pods, and they should be the same number. So if you want to see 1 of 1 and 2 of 2, and once everything is ready, then you know that once those numbers match, you know that everything is ready. Next, you want to use the kube control command line interface to get the external IP addresses. And for that, you use kube control get service or get SVC. And then you look for the ECL external IP from that response. And you'll notice that it's localhost. Well, we're running on a local machine, so that's what you would expect. But you still want to run this command because it ensures that the external IP is available and ready. Next, you'll access ECL Watch from a browser using the IP and port that we just found. In this example, localhost :8010. You can also use the ECL Watch IP in a configuration for either the ECL IDE, VS Code, or the command line tools.
For Minikube itself, you're going to be using the command Minikube service ECL Watch. And in this case, it will automatically start a browser for you.
And then when you're finished, you use the command helm uninstall my cluster to terminate the cluster. Now what this does, it stops the cluster, it deletes the pods, and it also deletes the storage used, along with all of your work units and all of your data. But don't worry, we'll get to that later where we'll talk about persistent storage. Now let's demonstrate what we just saw. In this video demo, we'll stand up a default HPCC Systems Platform from the HPCC repository. First, we'll add the repository to our Helm repositories using the Helm repo add command. Next, we'll update all of our repos, even though at this point it isn't really necessary. It's a good idea to get into the habit of updating before installing. Next, we'll install the default HPC systems chart using Helm install my cluster HPCC/HPCC and give it a version of 8.2.18. Notice the warning. The configuration contains ephemeral planes. What this is telling you is that when this is deleted, so will your data. We'll use kube control get pods to check the status, and we'll run that a couple times until we see that everything is running. And once they're all ready, we'll use kube control get service to see the external IP for ECL Watch. And you'll notice here that it's localhost. So we'll open a browser and we'll go to ECL Watch using localhost :8010. And there's ECL Watch. So let's run a job in the playground. We'll just pick the first one and hit submit. And it completes. And now we can look and we can see that the work unit has been created. Finally, we'll stop the cluster using the Helm uninstall my cluster command, keeping in mind that this deletes that work unit that we just created and any data that we might have had. So now that we've seen that, let's talk about persistent storage, because even in simple ECL development or testing or proof of concepts, you're probably going to want to keep some data around. So what we're going to do is we're going to create some local directories that we're going to use for storage. And there's a top level directory, and in Windows, this is in this example here, it's C HPCC data. In Mac or Linux, we put that under the users my user or whatever the username that you're using is, and also HPCC data. And then underneath that, there are 5 folders: Dolly Storage, Queries, Sasha, HPCC-data, and My Drop Zone. The names of the name of the top level one, HPCC data, is not hard coded. You can make that anything you want, but later when you do your Helm install and specify, you're going to have to tell it what your top level folder name is, and that has to match. The subfolders under it need to match the Helm chart that's in the examples. So it's easier if you follow, just use the names that we've provided. Now, if you're using Docker Desktop with Hyper-V, you're also going to need to add the shared data folder in the Docker Desktop settings. And to do that, just go to the Resources tab and select File Sharing, and then you'll click the little plus sign that's over here and add the folder. Next, you want to download the HPCC Platform Helm charts. And you can use either of our repositories for that, either the main platform repository or the Helm chart repository. And you can download that either doing a git clone if you have git installed, or you can use the download link that's on the GitHub page and just put it somewhere on your system. Next, you'll open a terminal window and navigate to the Helm folder of the repository you just downloaded. So then you're going to install the Helm chart from the examples local directory in your local repository. This chart creates persistent volumes based on the host directories that you created earlier. So for a WSL, the commands are a little bit different for different implementations here. If you're using WSL2, you do a Helm install HPCC local file. Now, in this case, that name is not arbitrary. That is required if you're going to be using the later example file that we're going to use. So this deployment has to be named HPCC-local file. And then you'll see at the end of that command, the set common host path equals. And that's where these 3 are different. And it's just based on the differences of the way that they mount or the way that they reference their host path. Now, there are 2 caveats. You have to make sure that, again, like I said, you have to make sure that you use the name HPCC-local file for this deployment. And the second caveat is that the folders underneath that common host file must exist. If they don't, your cluster will not start. Finally, you'll install the HPCC Helm chart and provide a YAML file that provides the storage information that uses the PVCs or persistent volume claims. And that is Helm install my cluster, HPCC / then add the version, and then a -F, which stands for I'm passing it a file. And that file is located in the examples local, and the name of the file is values-localfile.yaml. So once you do that, you use the kube control command line interface to check the status and get the IP addresses. So you want to know when they're ready, and now let's see that in another demo where we will stand up another. In this demo, we'll use 2 example Helm charts to create and use persistent storage. The first command, Helm install local file, references the chart and sets the common host path. This must match the top level local directory that you created. I created a folder named HPCC data on my D drive. Next, we'll do a Helm install of the HPCC Systems Platform, specifying the Helm chart in examples local. You'll notice this time there's no warning about ephemeral storage. Now we'll use kube control get pods to check the status. And we'll submit that a few times until we see that all the pods and containers are running. now that everything's running, we use control get service to get the external IP address. Even though we know it's going to be localhost, it's still a good idea to use get service to ensure that access is ready. Finally, we'll open ECL Watch using localhost :8010. And since we used a location that we've used before, you'll notice that all the work units, published queries, and logical files are displayed. They're still available and they'll persist even after we stop this cluster. So what are some tips on using Docker Desktop and some of these other tools? Well, one very convenient tip is you can start up your clusters and then just exit Docker Desktop. And when you restart it, your cluster is going to start up as well. So you don't have to start and stop it every day. You can just start and stop Docker Desktop. You can leave the HPCC local file deployment running and start new HPC system platforms to use it as needed. In your shell, especially if you're using a Linux shell, you can use aliases to reduce the amount of typing. And if you have more than one machine in your network, you can start a cluster on one machine and access it from another. Like I said before, feel free to contact either of us. Our email addresses are here. You can also use the conference interface to send us a message. Thank you.
Thank you.